Guys, welcome to South PyTech, and today we are going to learn about the repetition structures. In this video, we will be learning different types of loops like the while loop and the for loop. In this video, we will be covering the three topics. Number one, introduction to repetition structures. Number two, the while loop, a condition control loop. And number three, the for loop, a count control loop. So the remaining topics of 4, 5, 6, and 7, we will be covering this topic in our next video. So for now, let's start what is basically the repetition structures. So the concept behind the repetition structure is basically a repetition structure causes a statement or set of a statement to execute repeatedly. In many cases, a programmer uses a same program to repeat the same program one by one, and it doesn't mean that a programmer or developer has to write that program many times. If I want to run my program like 100 times, so I don't need to type that program 100 times, but instead of doing this, I have to create a loop that will run or execute that program for 100 times. So in this case, as you can see on my screen, here is a program, salesperson having a sales and a commission rate. So we have to, print the total commission in this case. So we can see there is a same program written 3 times. So when we will be running this program, so in the first case, when first program is executed or the first query is executed, the program is asking the user to enter the amount of sale, let's say $5,000, and the commission rate, let's say 0.25. So we can see the commission amount is $1250.0. So the first program is executed successfully over here, but you can see the asterisk. Asterisk means the program is still in continuation and is still in process and waiting for some response from the user. So over here, I have to enter the sale amount once again because now it's running for the second time. I mean the second program. So this is the amount and this is the commission rate 0.35, and we can see the commission is $3.350. Once again, now for the third time, the third program, the same program, we will enter the amount, sale amount, and the commission, let's say 0.74. So we can see the commission is $5,180.0. So now the program ends and completed, and we can see over here, we can see number one. So this program is executed for the first time, but the program was written 3 times in a same command window, and it executed for the 3 times. So this is not a good way. Basically, we have to design and we have to think that how we can run this program for the 3 times. Depends what are the condition. Okay, condition controlled and count loops. So in this section, we will look at 2 broad categories of loops: condition control and count control. A condition control loop uses true and false condition to control the number of times that it repeats. A count control loop repeats a specific number of times in Python. We use the while statement to write the condition control loop, and we use the for statement to write the count control loop. In this section, we will demonstrate how to write both types of loops. So the second concept, we will be learning the while loop, a condition control loop. A condition control loop causes a statement or set of statement to repeat as long a condition is true. In Python, you use the while statement to write a condition control loop. So over here, that we understand that when the condition is true, so our while loop will continue and continue until unless the condition get false. So over here in the flowchart diagram, we can see the logic at the back of a while loop runs in this way. Like in this, a rhombus, there is a condition of while. When the condition is true, a set of statement will execute over here and it will return back from the start. So program is basically starting from this point and it will come up to the decision box. If the condition will be true, it will run, it will go to the statement, any mathematical operation, operand, or whatever, and then it will go to the start and run again. And once it gets a false condition over here, so it will terminate the program over here. So the diamond symbol represents the condition that is tested. Notice what happened if the condition is true. One or more statements are executed and the program execution flow back to the point just above the diamond symbol. The condition is tested again, and if it is true, the process repeats. If the condition is false, the program exits the loop. In a flowchart, we will always recognize a loop when we see a flow line going back to the previous part of the flowchart. Okay. So here is the general format of the loop in the Python: while condition, a statement, and if there are several statements, so we have to use the indentation align with respect to this semicolon. So program shows how we might use a while loop to write the commission calculation program that was described at the beginning of this section. Okay, so once again, we can see we have a same program over here and up to here, and we are using the condition of while loop. So we can see we have assigned a variable with the letter y as a string in single quotation, and now we are using the while condition over here. While keep going is y, so we can see double is equals to, it denotes like the condition of y. If we want to keep this while condition true, so the variable keep going must be y whenever it asks at the end of the program over here. So when the condition meet the criteria, that is the y alphabet or the y string, so the program will be running again and again. Over here, it's taking the sales and commission from the user and doing mathematical operation over here. So it will print the amount over here. So let's run check. Okay, enter the amount of sales. So we can see the program have executed, and now we are at this stage like sales over here. So let's say sales $4,000 and the commission, let's say 0.28, and the program executed over here and printed the amount about the commission, that is $1,120. Now, as we have entered the while condition and we are using the while loop over here, so we can see the input from the user in the last statement keep going that we have assigned earlier. Now the variable is taking the input from the user to match the criteria that we have assigned in the while condition over here. So we have to enter the y. We are not using like a case sensitive, like we have to use capital or small. Right now we are just assuming we have to enter the y in a small alphabet or small letter over here. So once we enter y, you can see the program has executed once again, and our loop is maintained. And after this, when we have given the input y, the loops went again from the starting, they keep going, and now the program is asking the sales amount once again. So the commission rate, once again we have entered, and it has given the amount, the commission amount $2,649.60. Now if I want to terminate the program, so I can write or I can type anything, any character or any alphabet, whether it is small or capital, to terminate this program. So I want to make this condition false because I am writing another alphabet because I want to terminate and I want to end this program. So here I will write A, because when I will give the A condition, so the condition of keep going will not match at any level. So when I entered the A and now I press enter, you can see the program has terminated or ended over here. So it explains why we can assign a statement to create a variable name keep going. Notice that the variable assigned the value string y, small y. The initial assign value is important, and in a moment we will see why the beginning of a while loop which start like this: while keep going is equals to y. Noticing The condition that is being tested, keep going is equal to y. The loop tests this condition, and if it is true, the program is executed. Then the loop starts over. It tests the expression keep going y, and if it is true, the program is executed again. The cycle repeats until the expression keep going is y found to be false. Over here, we can see the diagram, the flowchart diagram of this program. So we have started the program from here, assigning the y to keep going over here. And this is the decision box. And we can see the while condition is applicable in this diamond box, keep going y. If the condition is true, it will prompt the user to enter the sale and assign the sale amount. And then we have to enter the commission amount over here, the input box. Then it will perform some mathematical operation, and it is doing the multiplication, says multiply by commission rate. Then it will display the commission, and over here it will prompt the user, and it will ask one again to enter the y for yes and assign the input to the keep going. So we have to assign the variable keep going, that is y, to make this cycle or the exercise or the loop as a true. So once we have entered true condition, the program will flow once again in a same manner. And once we have entered other than y, it will come to the false and terminate the program over here, and our program will be ended. So this is how while loop works. Okay, so let's move to the next example. This program assists a technician in the process of checking a substance temperature. Create a variable to represent the maximum temperature. Over here, we have assigned a maximum temperature variable over here, max underscore temp, with a value 102.5. Get the substance temperature. Float, we are taking the temperature in decimal. Input, enter the substance Celsius temperature over here. As long as the city instruct the user to adjust the thermostat while the temperature is greater than maximum temperature. So we are entering a temperature. If the number or the value that we are entering over here, we are giving the input to the program, it's greater than maximum temperature. If the value is greater than 102.5, so it will print the temperature is too high. Turn the thermostat down and wait 5 minutes. Take the temperature again and enter it. So we have to wait, and we have to enter and give the input once again over here within the while loop. So now we are giving two inputs over here before the while loop, because the while has to check whether the temperature is less than or maximum from the given maximum temperature that we have assigned already, 102.5. So once the condition is false or true, so we can see in true condition, it will prompt the user that the temperature is too high because the temperature is assigned with a maximum sign. So once the condition is false, like when I will enter or when user will enter the value less than 102.5, it will give, it will print the statement, the temperature is acceptable, and check it again in 15 minutes. So let's run and check what happened. Okay, enter the substance Celsius temperature. So if I want to make the condition true, I will write 130. So it will say the temperature is too high because the condition is true. The value we have entered over here, the temperature is greater than the maximum temperature. So the temperature is too high, and turn the thermostat down and wait for 5 minutes. Then take the temperature again and enter it. So let's say we have waited 5 minutes, and now I enter the value that is less than 102.5. So I will enter, let's say, 90. And we know that the condition now will be false because the 90 is not greater than maximum temperature. It's basically less than the maximum temperature, and when this condition becomes false, it will print this statement over here. So I have entered 90 and I will press enter. So the temperature is acceptable. Check it again in 15 minutes. So see, this is very cool example, and this example is similar to, that we have electronic cars and the thermostat or the car check engine lights and the radiator. When our radiator or the bottle, the engine temperature blows away, like it exceeds any required condition, any Celsius or Fahrenheit, so it gives a check engine light or the warning light that the radiator is getting hot, and we have to wait for a few minutes to cool down the engine or to service or to maintain the car engine or check whatever the issue is in the radiator. So this is the logic behind that thing that we are having in our car temperature or engine temperature. Okay, so let's move to next topic, infinite loops. In all but rare cases, loop must contain within themselves a way to terminate. This means that something inside the loop must be eventually make the test condition false. The loop in previous program stop when the expression keep going y is false. If a loop does not have a way of stopping, it is called an infinite loop. An infinite loop continues to repeat until the program is interrupted. Infinite loop usually occur when the program forgets to write a code inside the loop that makes the test condition false. In most circumstances, we should avoid writing infinite loop. So in this case, we can see this is the same program. This is the same example that we have done previously, the sales commission. So difference between this, that we are assigning the keep going variable y over here, but we are not taking the input from the user within the while loop. So you can see after this, if I move upward once again, so we can see we are taking the input of keep going y variable. So when we enter the y, it goes once again to the loop from the while condition. And if the condition is true, so the program decide whether to run again to execute or false to terminate. In this case, we are not taking any input from the user. We have just designed a program that is running and running, but not taking any decision given by the user as an input. So now we are giving the amount, sale amount over here, and the commission, let's say 2.5. You see, the commission is displayed $250, and because of no decision, because of no input, or because of not reassigning the variable that is keep going y, we can see our file while loop is running and running and running. So in this case, this is a while loop that is infinite loop, right? So if I enter the amount, and once again if I enter the commission, so you can see the program is running and running. So in this case, we have to terminate and we have to forcefully stop this program over here by clicking the interrupt the kernel over here, the button, the square button over here, the stop button. So we have to forcefully stop and terminate this program over here, because there is no such condition that make the while condition true and false. And by default, the condition is getting true over here because we have already assigned the keep going variable y over here, right? So let's terminate this program over here, and there is an error, and it says the keyboard interrupted by the user. So we have terminated this program forcefully, right? So it is necessary that we have to assign a condition in a while loop, that is necessary. And this program also say that in most circumstances we should avoid writing infinite loops. Let's move to the next topic, that is topic 3, the for loop, account control loop. So a for loop is basically a very important topic that we use in our daily life and in developing environment, or what we are making as a programmer. So in each and every program, we are frequently using the for loop condition over here. And okay, the concept behind the for loop, account control loop iterates a specific number of times in Python. You use the for statement to write a count control loop. As mentioned at the beginning of this section, a count control loop iterate a specific number of times. Count control loops are commonly used in the program. For example, suppose a business is open 6 days per week, and you are going to write a program that calculates the total sales for a week. We will need a loop that iterates exactly 6 times. Each time the loop iterates, it prompts the user to enter the sales for one day. We use for statement to write a count control loop. So in Python, the for statement is designed to work with the sequence of data items. When the statement executes, it iterates once for each item in the sequence. So here is the journal format of the for variable. So over here we have written for variable in value 1 2, and we are giving the range in a square bracket. Over here we are using the semicolon, and after semicolon we can see we have to follow the indentation and alignment as per for loop. So in this program, this is a simple program for loop. We can see we are printing over here. I will display the number 1 through 5, and over here we will be understanding what is iteration, basically how for loop work. So for the num, we have assigned a variable num. So for num in the series 1 2 3 4 5 and semicolon, when we enter and you can see the cursor, it's automatically intended or aligned by a tab spacing from the margin over here. And after giving the for loop, we are printing the variable over here, the print num. So what happened? Let's run and check how this program run. So you see we have printed, I will display the number 1 through 5, and the for loop running in a manner like it's printing 1, then in the next iteration it's doing 2, in the third iteration it's printing 3, and in the fourth iteration it's printing 4, and in fifth it's printing the fifth number over here. So how for loop work, it's you can see from the this diagram or the the methodology. In the first iteration, the for num, so num is a variable that is assigned in a series in a square bracket. So in the first case, in the first iteration, the num is the one, the one is aligned, is assigned to the num, and print will print the num. So one, when is assigned in the first iteration to the num variable, so num will print the number 1 over here. So when 1 was assigned to the num, so over here it printed the 1 digit over here. In the second iteration, the for loop runs, the 2 is assigned to the num, and the print function has printed the 2 digit or the 2 numbers. In the third iteration, the 3 is assigned to the num, and print has printed the 3 digit. In the fourth iteration, the 4 is assigned to the num, and the print has printed the 4 number. And in the last and the fifth iteration, because there are 5 numbers over here, so 5 is assigned to the num, and print has printed the 5th number over here. So it doesn't mean that we are running the for loop for the 5 times, but it means we are running the for loop for the first for the single time, and we are just running for the for once. But the functionality of the for is like that, it reads the numbers that are assigned in the list, so it's go one by one and one by one. So this is the case where we can see you can see the numbers are printed in every next line, like 1 2 3 4 5. They are not printed like in a single line because there are iteration. So in the first iteration it printed 1, in second 2, in third the 3, in the fourth it printed 4, and in the fifth it printed the 5. So Python programs commonly refer to the variable that is used in the for clause as the target variable, because it is target because of an assignment at the beginning of each loop iteration. The values that appear in the list do not have to be consecutively ordered series of number. For example, below program uses a for loop to display a list of odd numbers. There are 5 numbers in the list, so the loop iterates 5 times. Over here, we are using the odd numbers over here. The example is same that is above. Over here, we have just written the numbers that is are in odd. So when we will execute, it will print the odd number over here. Over here, we can see now they have introduced some string values, like over in the previous example, we can see we have written the values without single quotation because they are the numbers, integers. Now we can see the values are in a string format. So it also explains that in for loop, we can also print the string values. The names are written over here. So the names are assigned by a variable that is name, and for loop iterates winking, blinking, and not, and it will execute 3 times. So 3 iterations are performed over here, and it has printed the string values winking, blinking, and not over here. Using the range function with the for loop. So this is very important topic, the range function. Python provides a built-in function named range that simplifies the process of writing a count control for loop. The range function creates a type of object known as an iterable. An iterable is an object that is similar to a list. It contains a sequence of values that can be iterated over with something like a loop. Here is an example of a for loop that uses the range function. So we can see in previous example, we are giving values in a list within the square brackets. Now we are using the range function, and we can see we have written the 5 over here, and the function is exactly the same that we are doing above. So we have assigned the for loop, we have assigned the x in for loop, and we have given a range function over here. So range is a built-in function in Python. We can see we have given the range 5 over here, and we will print the hello world over here. We assume that this hello will be printed 5 times over here. So let's execute. Okay. So what we assume, it went quite right, and we can see we have printed the hello world over here 45 times. So it says if you pass one argument to the range function, it's as demonstrated in previous program, the argument is used as the ending limit of the sequence of the number. If we pass two arguments to the range function, so the first argument is used as the starting value of the sequence, and the second argument is as the end limit. Here is an example. So we can see we have the starting range and the end limit of the function, and over here we will print the range by giving the starting range and the ending limit. So if we see over here, we have given the range. We assume that 0 is starting and 10 is the limit over here. So print num. So num is assigned to the range. Okay, let's execute and check. So we can see 0 is the starting limit, the starting range, and we have moved towards the up to the 9, but we can see we can't see the 10 digits is printing, but we can see that if we count complete numbers, they are total basically 10. So what happened over here, we can see in this for statement 3 argument passed to the range function. The first argument, that is 1, that is the starting value for the sequence. The second argument, that is 10, it is the ending limit of the leads. This means the last number in the sequence will be 9. So the 10 is excluded, 10 is not included, right? So if we want to include the 10, we have to give the 11 over here, and we have to print once again this range. So we can see the range is uh, from 0 to 11, and 11 is not included. Okay, so this was the example of the starting and end limit. Now there is a step function, like if I give 2, so what happened, this is the step value. The third argument 2 is the step value. This means that 2 will be added each successive number in the sequence. So what will be happen, like the range is starting from 0, it will ignore the 1 and it will come to the directly 2 and it will print the 2. It will ignore the 3 and it will jump to the 4. Now over here in this case it will jump to the 6 and then 8 and then 10, but 10 is not included because we have given the number up to 10. It will end up to 8 over here. So it will, when we execute this program, we can see we are printing 0 starting from 0, and this step function is 2. It has given 2 successive number over here, then 4, then 6, then 8. So if I write like 3, so it will goes to 0 directly from 3, 6, 9. If I enter 4, so it will go to up to the 8 because the next number is not included in the range. If I type 20 over here, so we can see we go to like 0, 4, 8, 12, 16 over here. So this is basically the step function, and it allows the user to move the stepwise. If we enter the 1, so it's a simple by default. So this is a quite interesting function for range function in a for loop. Okay, using the target variable inside the loop. In a for loop, the purpose of the target variable is to reference each item in a sequence of items as loop iterates. In many situations, it is helpful to use the target variable in a calculation or other task within the body of the loop. For example, suppose we need to write a program that displays the number 1 through 10 and their square in table similar to the following. the program use a loop to display the table showing the number 1 through 10 and their square. So over here we can see we are printing the heading and the underline or the scores, right? The dashes basically. We can also see we have written the backward slash and T. It's basically a tab spacing. So I will explain you what is the tab spacing. Okay. In the for loop, we can see we are assigning a variable number within a range 1 to 11. We have written 11 because we want to include the 10 number over here. So every number when iterates, it get a square because we have assigned double asterisk. So in Python, double asterisk means that you are going to raise the power of that number up to 2. And once again, we are printing, and you can see we are printing three things over here. The number that we have assigned in the range, the T is not basically the string, but it is a tab spacing. So I will explain you what is tab spacing when I will execute this program. And the third is square. A square is the mathematical operation that we are obtaining by multiplying, by doing the exponential function, and number raised to power 2. We are making the square. So let's run and check. We are basically doing the square of each number. So over here we can see the number, and there is a space between number and a square. So this space is basically because of backward slash and T. This is a formatting a tool or formatting thing in Python. So if I remove this tab, we can see the number and square are now combined together. So once again, I have to write the backward slash and T over here. Similarly, we can see the tab spacing over here. If I remove this and if I run this program, so you can see the now numbers are concatenated or merged. So this is not a quite good presentation over here. Okay, so this was the tab spacing by denoting backward slash and T. So what happened? We can see the number 1 through 10. So this is the range 1 up to 11. So 11 is not included, and we have printed up to 10. And over here we can see each number that is iterating, that is getting a square. So 1, when assigned over here number, it went to the square. So the square of the 1 is 1, then the 2 is iterated, the square of the 2 is 4, and the square of the 3 is 9, and so on. The square of the 10 is up to 100. So how this program works, we can understand this flowchart diagram. We have assigned the start function over here, display the headings. This is the diamond box, the decision of for loop, right? So we have given the range over here. If the all iterations are getting true, the assigned number is getting assigned to the number variable, and that number is getting a square each time at every iteration, and this number is getting printed in a square. So in each and every item, the number is getting printed over here. That's why it uses every single line. So the iterations, there were total 10 iterations, and each number were printed for the 10 times over here. So when iterations got ended, the program terminated false and end over here. So this how we have printed the table with exponential over here, right? Okay, the program convert the speed 60 kilometer per hour through 130 kilometer per hour in 10 kilometer per hour increment. Okay, so now we are just playing with the same range function by assigning a variable. Now we have assigned a starting variable that is 60 and the speed is 131, and the increment is 10. So we can see this is starting range, this is end range, and this is the step function that is increment, and the conversion factor is 0.6214. We have assigned the heading with same that we have written over here, the number square by tab spacing the underline, and over here we have assigned the kph in range, start speed and end speed. We have given the starting and end limit over here, and the step function is increment over here, that is 10. So every increasing the speed by 10 kilometer per hour, the factor will get converted by multiplying conversion factor, and we will obtain the mile per hour. So once we obtain the mile per hour, we will then print the table, the kph tab spacing, and we are following the formatting rules of Python. It will give the units in mile per hour. So over here we can see the starting is 60 and the end limit is 130, and every conversion factor, the number or the kilometer per hour speed at every increment of 10, it's getting converted over here, and we are using up to 3 decimal place. So if you want to use like 1 decimal place, you can see the 284 will come to 1 decimal place over here. So it is rounded up to 3, and we can see the decimal is now removed. So if I want to remove completely, so we can see now the values are in whole numbers. So these are basically the formatting rules that represent the data in a good way. We can use this formatting in Python very easily. So this how range function was in converting the mile per hour and kilometer per hour. We can also use this program, the range function, by conversion factor, letting user to control the loop. So this is the same example, the the square and the number. We are just giving the end range over here, and the starting range is from 1, and the table is getting printed over here. So how should I go? Okay, go up to 20. So the numbers are getting square. Previously it was about up to 10, and now I'm getting 20. So we have just assigned the end, and we are using end plus 1 function over here, because when we assign 20, so it means 20 is included. The user want 20 to display the square. So for 20, we have to assign plus 1 to make it 21, because 21 is not included, but the value before 21 is included, that is 20, and that user has given the input the end limit, and he want to see the result of 20. Over here, the program uses a loop to display table of numbers and their square. So the program is same once again, and we are taking the starting limit and end limit in the range function. So once again, we have to give the starting number and end limit up to, let's say, 15. So 15, we want to see the 15, the square of the 15 over here. So we have to give 1 plus 1, because when it will come to 16, so 16 is not included, but the value before 16 is included, that is 15. So guys, the last topic, generating an iterable sequence that ranges from highest to lowest. Okay, so this is basically the range function. Now we are using in the descending order, the number assigned to the range 10 to 0, and we are using the step function minus. So let's run and check. So we are using 10 to 1 in descending. So let's check if I give a positive value, what happened. So it gives nothing, and it displayed nothing, because this is something an unusual abnormal behavior for the range function. So if I assign negative value over here, it once again print the descending order. So this was the last example of our topic, and we will be covering the next topic from 4 onwards, that are basically calculating the running total, the sentinels, input validation and loops, and nested loop. So guys, I will share this Jupyter notebook in my comment section in my description. If you like my video, kindly do subscribe my channel, give your feedback, give your suggestion. Thank you so much, guys. Take care. Bye bye.